Assalamualaikum to Madam Adibatul Husna and to our viewers. My name is NURIZZATI SYAFIEYA binti ANUAR and my partner DINI binti AZHAR. Today we'll be presenting our topic on crystalline solids with a focus on zinc oxide and its applications in skincare. We hope you enjoy our presentation.
To give you an idea of our journey today, here is our roadmap. We'll begin by defining the core concepts of crystalline solids and how they are classified. From there, we'll dive into the fascinating world of zinc oxide, looking at its structure, properties, and why it has become the gold standard in modern sunscreen technology. We'll also analyze some data on its effectiveness, discuss its environmental impact, and take a quick peek into the future of this material. To keep us on track, I've outlined our goals for today. First, to introduce the concept of crystalline solids and their classification. Second, to connect zinc oxide's crystalline structure with its characteristics and properties. Third, to highlight the applications of zinc oxide in everyday products like sunscreen. Fourth, to provide learners with a clear understanding of how solid-state chemistry concept applies to practical materials used in technology and industry.
So, what is a crystalline solid? At the molecular level, a crystalline solid is a material where the atoms, ions, or molecules are arranged in a very neat and repeating pattern. Unlike amorphous solids, where the particles are randomly arranged, crystalline solids have a highly organized three-dimensional structure. A good example would be diamond or table salt. Their regular arrangement is what gives them their strength, stability, and predictable properties. Now, let's look at zinc oxide. Zinc oxide is an inorganic compound that usually appears as a white powder. However, what's really important is its crystal structure. Zinc oxide is known as a wide bandgap semiconductor, which means it has special electrical and optical properties. Because of these properties, it's widely used in products like sunscreen, rubber, electronics, and sensors. So, what does its crystal structure look like? Zinc oxide forms a hexagonal quartzite crystal structure. You can imagine it as a repeating honeycomb-like pattern that extends in three dimensions. This arrangement of zinc and oxygen atoms is very stable, giving zinc oxide its durability and allowing it to interact with light effectively. That's one of the reasons why it's so useful in many modern applications. So, as you can see, this one is the equation of zinc oxide with acid and with strong bases. This reaction actively soaks up excess oil. It explains why zinc oxide has a clinical astringent and mattifying effect, which benefits oily skin but can cause severe dryness, flecking, or a tight sensation on patients with a compromised or dry skin barrier. In cases of heavy sweating or highly acidic skin environments, a minute amount of zinc oxide may break down into zinc 2+ ions. While zinc 2+ ions are highly soothing and anti-inflammatory, which is why zinc is used in diaper rash creams. In rare individuals with compromised skin barriers, it can trigger localized contact dermatitis.
First, we have its ability to reflect UV rays. Zinc oxide is highly effective as a broad-spectrum absorber, reflecting both UVA and UVB light. It is one of the most trusted ingredients approved by the KKM for sun protection and is a staple in mineral makeup for this very reason. Second is its insolubility in water. This is crucial for performance because zinc oxide is practically insoluble in water. It stays on the surface of the skin, ensuring your sunscreen remains effective even when you're sweating or exposed to moisture, rather than dissolving away. Third, there is its chemical stability. Under normal conditions, zinc oxide is incredibly stable. It doesn't readily recompose or react with other ingredients in your sunscreen, which is a major factor in ensuring the product maintains its efficiency and provides a longer shelf life. Moving on to the secondary yet equally vital properties of zinc oxide. First, let's discuss thermal stability. One of the key advantages of using zinc oxide in sunscreen formulations is its ability to withstand high temperature without decomposing. This thermal resilience is crucial because it helps maintain the integrity of the formula, directly contributing to a longer, more reliable shelf life for the final product. Next, Next, and perhaps most importantly, is its UV absorption and scattering capability. Zinc oxide is a powerhouse here. It physically absorbs and scatters harmful ultraviolet radiation, providing broad-spectrum protection against both UVA and UVB rays. This dual-action mechanism is exactly what makes it such a gold standard ingredient for effective sun protection. Finally, we have low reactivity. Compared to many other chemical compounds, zinc oxide is remarkably unreactive because it doesn't easily participate in chemical reactions. It is exceptionally safe for topical application. For the vast majority of users, this means minimal risk of irritation, making it a gentle and reliable choice for skincare. In terms of advantages, zinc oxide is a true powerhouse. It is non-comedogenic and recognized as the gold standard for sensitive skin. It sits on the surface of the skin as a physical blocker, which significantly reduces the risk of irritation compared to chemical alternatives. However, it is important to address the challenges. Historically, the main disadvantage of zinc oxide was the white cast it left on the skin. Because the particles were bulky, they scattered visible light. Additionally, if the formulation is balanced correctly, it can sometimes feel slightly heavy or chalky upon application.
It is important to look at the broader picture, including the environmental footprint of our sunscreen choices. When we talk about zinc oxide, we're looking at a generally favorable profile, especially when compared to certain chemical sunscreen ingredients, as it is considered less harmful to marine ecosystems. However, it is crucial to remain mindful of a few key factors. First, the scale of impact, even with safer alternative. Large concentrations of any substance entering our waterways can affect aquatic life. Balance is key. Second, we have to consider nanotechnology. While effective in formulations, nano-sized zinc oxide particles can accumulate in the environment. Because their long-term ecological impact is still being studied, this remains a subject of ongoing research. Finally, our role as consumers. The scientific community is actively working to better understand these effects. In the meantime, we can all contribute to minimizing our environmental footprint through responsible use and proper disposal of our sunscreen products. To put these properties into context, let's look at some real-world examples currently on the market. Several brands have successfully utilized the benefits of zinc oxide to create effective, user-friendly sun protection. Specifically, products from brands like AZHAR, Cliff, The Raw, and Helios demonstrate how zinc oxide can be formulated into high-quality sunscreens. These brands highlight the versatility of the ingredient, proving that you can achieve a lightweight feel and effective broad-spectrum protection, all while maintaining the safety and stability profiles we've just discussed.
To overcome these disadvantages, we utilize nanotechnology. By micronizing zinc oxide into nanoparticles, we can keep the protective efficiency against UV rays while making the particles small enough to be transparent on the skin. This solves the white cast issue while keeping the benefits of the crystal structure intact. First, the eco-friendly formulations. There is a strong push to create environmentally friendly sunscreen formulas that reduce ecological impact, ensuring that the ingredients we wash off aren't harmful to marine life or ecosystems. And then the user comfort. A major focus is on improving the texture of the sunscreen. The goal is to make the application experience more comfortable and easier for the user, ensuring that people are more likely to wear it daily. The third is performance enhancement. Developers are working on hybrid sunscreens. This combines zinc oxide with other UV filters to provide even higher levels of protection and better performance across different skin types and environments.
To understand the real-world impact of these products, let's look at the data. This chart tracks sunscreen usage trends among adults in 2020, broken down by gender and age groups. For instance, note the peak in the 30 to 44 age range for both groups, which might suggest a heightened awareness of skin health and anti-aging benefits during those years.
So in conclusion, zinc oxide's crystal structure makes it a perfect physical barrier against UV rays. It is safe for sensitive skin and thanks to modern technology, it provides high-level protection without leaving a white residue. Ultimately, this proves that understanding crystalline materials is the key to creating better and safer everyday products.